Welcome back to Science Mathematics. Welcome back to this video. Today we are going to see a question on mathematics with statistics and precisely on correlation and linear regression. So for all those going in for the advanced level GC examinations, Science Mathematics and Objective Corporation wishes you the best. So learning never ends. Values are gained each time you learn something new. The process might not be easy, but if you are at this stage, it means you have and can endure the whole process. So don't give up and press on. Objective Corporation and the CIMO team wishes you the best in your GC exams. So let's get started with our video. So the question reads, in a certain high school, the performance of 10 students in two subjects, French X and English Y, during the first sequence evaluation were recorded as shown below. So we have the French marks and we have the English marks. So as displayed on the table, we see that we have 10 different outputs or 10 different outcomes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the question says A. Calculate correct to 3 decimal places the product moment correlation coefficient between the French and the English marks. B. The equation of the regression line y on x. C. Estimate the French mark of a student who scored 40 marks in English. And D. Calculate the Spearman rank correlation coefficient between the French and the English marks. So the total is 13 marks. So let's get started with the first part, which is calculating the product moment correlation coefficient between the French and the English marks. Okay, so to find the product moment correlation coefficient between the marks, that's the French and the English marks, we simply use the correlation coefficient, which is given by R is equal to the sum of xy. We have the sum of xy minus the sum of x times the sum of y divided by n. All of this divided by the square root of the sum of x squared minus the sum of x, all of that squared on n, times the sum of y squared minus the sum of y all squared divided by n. Now, in most of the cases, which is not the case in this question, the values of the sum of xy are given to ease calculation, so that you just come and do numerical application. That you just substitute the values inside here and you get the product moment correlation coefficient. And we have to notice that this value actually determines the strength which exists between the two variables, that's x and y. The closer we are to 1, the closer we are to positive 1, the stronger the relation is. Than the further away we are from 1, the weaker the relation is going to be. Okay, so here we are going to draft a table where we can actually compute our sum, the xy's. We are going to compute xy's, then we get the sum. We are going to find the sum of x, the sum of y. So the only variables we're given are x and y, as in the table, the initial table in the question. Now to get this, we proceed by drawing a table which is already filled. So we have the x value. This x variable is what was given in the question, and so x was 54, 52, 42, and so on and so forth. And so here we have the sum. So the sum is everything in red. So the sum is 376 for all of this. You can also use your calculator to verify all this information. In case of any mistake, you can drop your questions on the comment section. Now likewise, we have the y. We sum all the y, we have 598. Now xy means we multiply x times y. For example, if you take 54 times 84, it will give you 4536. And if you take 52 times 68, we take the second 52 times 68, it will give us 3536, and so on and so forth. So you can verify all those calculations on a calculator in order to be in phase with the video. So make sure your calculator is on your hand while watching this video. Okay, so the next is the sum. So after we have calculated everything that's from 1 to 10, we now obtain the sum, and the sum gives us 23,776. Now the next is we have x squared. All these parameters are taken from this formula, so we see what we need. We need y squared, we need x squared, we need the sum of x, we need the sum of xy. So here we have x squared, so we take 54 squared, which will give us 2,916. So you can verify that with your calculator. And we have 52 squared, which is 2,704, and so on and so forth, right up to 13 squared, which is 169. And so when we sum all of these values on that column, we get 15,686. Next, the same with y. So y, we obtain y squared, so 84 squared will be 7,056, and so on and so forth, and we take the sum, which gives us 38,314. Now we see clearly that from the table one can deduce that the summation of x is 376. That's it. Here we have sum all the values of x. We have the summation of y is 598. We have the sum of x times y, so we sum xy, it will be equal to 23766. And lastly, we have the sum of x squared, it's 15,686, and we have the sum of y squared, which is 38,314. And so with this we can calculate the product moment correlation coefficient. So numerical application, we yield R will be equal to the sum of xy, which is given, which is 223,766, minus the summation of x, which is 376, times summation of y, 598, divided by the number of observations. So we have n is 10. All of this divided by, I will use a big bracket and raise it to the power half. So the summation of x squared, so summation of x squared is 15686. So we have 15,686, minus the summation of x all squared. Summation of x is 376, all of that squared, divided by 10, and this times summation of y squared, which is 38,314, minus summation of y, 508, all of that squared, divided by 10. So we close the bracket, and I close the big bracket and raise it to the power half. So that raised to the power half is the square root. So now we punch that value from on our calculator, and we get the correlation coefficient. So we have 23,766. So 376 times 598. Okay. So above we have 1,281.2. So here we have R is equal to 1,281.2 divided by, let's simplify what is under. So here we have 15, the first bracket gives 1,548.4. So we'll have the square root of 1,548.4 times the second bracket. So it gives 2,553.6. So times 2,553.6. So this will be equal to So we have 0.644. I said we leave it to 3 decimal places. So the R is 0.644. So that value is too far from 1. So it definitely tells us that the relationship between x and y is not that strong. So that's the product moment correlation coefficient for this data. Okay, so let's go to the next question. Okay, now the next question says we should find the equation of the regression line of y on x. Now our data will still be useful. Now notice that the regression line y is always equal to a certain b0 plus b1 x. So it's an equation of a straight line. So this regression line actually is a line which shows the relationship which exists between those points. And so b1 here is the regression coefficient. And so to calculate b1, which is like the slope of the graph, so b1 is simply given by n times the sum of xy minus the sum of x times the sum of y, all of this divided by the sum, n times the sum of x squared minus the sum of x, all of that squared. So that's the relationship to calculate b1. So this for the regression line of y on x. But the regression line of x on y, what remains up is the same, but what varies down is simply x, so it becomes y here, y here. Okay, so we calculate b1. So let's do the numerical application. N is 10, summation of xy, and summation of xy is 23,776. Log minus summation x times y. So we have 376 times 598. All of this divided by 10 times the sum of x squared. Sum x squared is 15,686 minus summation of x all squared. That's 376. All of that squared. So numerical application implies b1 b equals to times 2,776 minus. So what is on the numerator gives 12,000. This gives 12,912 divided by what's on the denominator. So 15,484. So here we have 15,484. And so B1 numerical application will be 1291 12912. So it'll be 0.833, so 834. So this will be 0.834 to 3 dps. Now I'm not going to round up this to calculate b0. Now b0 is simply equal to, we have the sum of y is equal to the sum of y minus b1 times the sum of x divided by n. b1 times the sum of x divided by n. And so this means our b0 will be equal to the sum of y is 598 minus b1. Our b1 is, I will use 12912 divided by 15 0.484. So I'm using this full value because I don't want to approximate. I don't want the approximation to be too much. So all of this will be multiplied by 376. All of this on n, where our n is 10. So this will be equal to 376. So it's going to give 28.446. That will be 28.446. And so the equation of the regression line will simply be y is equal to b naught, which is 28.446 plus b1x, that will be 0.834 times x. So that's the equation. Now, the notice that we saw that the relationship between both variables are not really strong because the correlation coefficient was very small, so it was too far from 1. Now we can take a value of x to verify the value of y. Let's take, for example, we should use the point. You can use any point. You can use the point 40, 60. Let's actually check the relationship between the two. So it means that this is our regression line. So we can keep this answer. Now, if x is equal to 60, let's get, so if x is 49, let's see what it's going to give. So that will be 28.446 plus 0.834 times 49. So let's see if it's really going to give us something close or a little bit far from 60. Plus 28.446. So it gives us 69.312, and you see here that we have 60. So that reason is simply because the relationship between both variables is not that strong. So this gives 69.312. 69.312. Now there are some other points that will definitely give you the right value. For example, let's check 1361. So when x is equal to 13, we have 0.834 times 13. That's times 13. Then plus we have 28.446. Yes, so still too far. So that's actually it. So it is because of the correlation coefficient that we saw. The relationship between both variables is not really that strong. Okay, so let's proceed.
Now, the next question says that we should estimate the French mark of a student who scored 40 marks in the English test. Now, we are going to use our equation obtained above. Y is equal to 0.834x plus 28.446. 28.446. Now, we had our French mark to be x and we had our English mark to be y. So if you make x the subject, x will be 28.446 minus 0. Sorry, minus, so that will be 28, the reverse. So it's going to be y minus 28.446. All of this divided by 0.834. And so our y is 40. So we have 40 minus 28.446. All of this divided by 0.834. And so let's do the numerical application. So we have 40 minus 28.446. So it gives 13.85. The decimal places, it will give 13.854 to 3 decimal places. Now the next says calculate the Spearman's rank correlation coefficient between the French and the English marks. So here, the Spearman's rank correlation coefficient is rho, which is given by 1 minus 6 times the sum of the I square divided by n into n squared minus 1, where n there are the number of observations and the I is the difference between the rank. So we are going to complete the table which is seen here. You see that here we need the rank of x, the rank of y, and d squared. So d can be in absolute value, so be positive or negative, it doesn't disturb. D is simply the difference between the ranks. So we are going to rank our data. So let's begin with the ranking of x. Rank is just like position, so we are not going to consider this is our sum, so that's the sum. So we are going to rank the data, so it's like giving positions onto these numbers from the highest to the least. So the highest will be the first and the smallest will be the last, which is the 10th. So amongst the x, we see that the greatest of the numbers is 54, so 54 takes rank 1. Now it is followed by 52, which is the second. The next number will be 49, so 49 is the third. And the next will be, after 49 we have 43, which is the fourth. Then 42, which is the fifth. We have after 42 we observe 37, which is the sixth. Then 37 we go to 32, which is the seventh. 31, which is the 8th. 23, which is the ninth. And 13, which is the last, the 10th. So we do the same for the rank of y. So the rank of y, the biggest observation we see is 84. So here is rank 1. We have 68. 68 we give the next will be 79, which is the second. The next after 79 we observe 68. Now we observe 71, which is the third. Then 68, which is the fourth. Then we have 61. Yes, we have 61, which is the fifth. We have 60, which is the sixth. We have 58, which is the seventh. We have 47, yes, 47, which is the eighth. Then we have 37, which is the ninth. And we have 33, which is the 10th. And so now we calculate d, which is the difference between the ranks. So here we have 1, the rank of x minus the rank of y, or the rank of y minus the rank of x. So in most cases you can also take the absolute value, so that you just write down the positive result. But no matter what you write, d squared will still be positive. So we have 1 minus 1, which is 0. 4 minus 2 gives 2. 3 minus 5 gives negative 2. Or you can still write 2. There's no problem. Then we have 9 minus 8, which is 1. 2 minus 4 gives negative 2. 7 minus 9 gives negative 2. 10 minus 7 gives 3. 6 minus 3 gives 3. 8 minus 6 gives 2. And 5 minus that gives negative 5. 5 minus 10. Now we square. 0 square is 0. 2 square 4. Negative 2 square 4. 1 squared 1. Negative 2 squared 4. Negative 2 squared 4. Here is 9. 3 squared 9. 2 squared 4. 5 squared 25. And so now we obtain the sum of the I square. So the sum will be 0 plus 4 plus 4 plus 1 plus 4 plus 4 plus 9 plus 9 plus 4 plus 25. So it's going to give us a value. So we have plus 4. So it gives us a total of 64. So here we have a total of 64. So therefore, the Spearman's rank correlation coefficient will be 1 minus 6 times 64 divided by number of observations 10 into 10 square minus 1. So that will give 1 minus 64 times 6 gives 384. 384 divided by 10 square is 100 minus 199 times 10, which gives 990. So the final result will be 384 divided by 990. So we get that this is equal to 0.612 to 3 decimal places. So when you observe this and what we had above, that's the coefficient of correlation, you see that the difference is not that vast, it's not that much. So it simply tells us that sometimes the Spearman's rank correlation coefficient can be approximated to the coefficient of correlation R in just some few cases. And also it tells us that the relationship between these variables are really is not that strong, reason why it is a little bit far away from one. So this brings us to the end of this video, and if you are not subscribed to this channel, please endeavor to do so. Like, share and subscribe this video, and best wishes for your GC examinations 2024.